Here in this application, we're just going to do a quick proof of concept. And here you can see I've got the AR2500 Laser Sensor. It is one of the older models, so it doesn't have the new high-speed firmware update. But as you can see, I've taped on a glass over the top of it. And what this glass is it's a micro slide. So this is just a microscope slide made, so it's a piece of glass about 1 inches by 3 inches, very good optical qualities, and it's a precision pre-cleaned glass. So in thickness, it's about roughly right at 1 millimeter, about 40 thousandths of an inch. And these are typically very accurate, thickness-wise, very constant sort of optical quality glass, and pretty inexpensive. So I would recommend that you possibly look at they do have a 2-inch by 3-inch, which give you a lot more coverage. Here you can see I've only got about 3/4 of an inch over the laser itself, and the intent of this is to show you that we can get a very good signal. And let's just shrink this down. So this is let me just shrink the size of this. Just having a little digital problem with the mouse here. So here you can see once again we've got the data streaming out in meters. And so what happens when we put this clear replaceable lens flat over the laser itself? So what it does is it actually generates an offset. So what that means is it's actually measuring about 6 inches off, and that'll be linear through the range, but that is correctable. So as an example, just to show you, I've got a little laser measurement here, and I'm showing roughly 1.559 meters. And if we look at here, we're seeing about 1.44. So it's roughly about somewhere between 0.15, 0.6, 0.7, somewhere in there. There's that offset, which is right at about 6 or 7 inches. So that should be very linear through the full range. So most of my customers, they would mount this, they would measure a known height on it, and then of course they would zero it in and add the offsets of that height so that they would then be able to measure correctly. So the main intent is to show you that by putting on this clear window, you can see as I move it around, I'm not having any problems. I haven't tried this at high speed because this doesn't have, the Windows hyperterminal here is not high speed enough. And so if we look at the output, and then let's just take this glass off, and I just have it mounted with Scotch tape. And let's just take a quick look at what the glass does. So by putting it up flat against here, we're at about 1.43, and by putting it up flat against there, not too big a change really, right? So, and as I move that glass out, you can see what it does to it. It introduces an offset. I'm still measuring right through that glass, and part of this is just mine. And as I angle it, you can see, even when I angle it, I mean, the laser, it is introducing offsets, but the laser is still measuring through it very accurately. So I think it'd be very feasible to make a little mounting plate with the correct size, and to be able to, even if you had a little 3D printed part, that would be like a little suction cup over here, where you could put that little glass attachment over here, put it on your sensor, zero it out at the correct reference distance, and then it should be a lot easier to clean and to keep the laser from getting any scratches on its outside lens.